Let's now add a second class to our model cluster, birthday book, which is going to make use of the birthday class that we have developed previously. So let's click on model cluster and then click on add a new class button there. And then let's type birthday underscore book precisely. Okay, and then we say create, and we should expect the compilation to be succeeded. Okay, it's now just compiling. If it does freeze like this, I would say there are two things you can try. Go under project over here. You can either say find the edit class and recompile, or you can simply recompile from scratch. Why don't we try recompile from scratch since we haven't illustrated to you how it works? So I would say, because Eiffel does incremental compilation, so anytime if you try to, you have developed for a while, and then things don't really seem to work as they are supposed to work. In that case, maybe the generated C code is not really working well, so you may want to recompile from scratch by following what I just did. Again, projects, and then compile from scratch. That's always the option you can try before you debug further. Okay, so now that we have got our birthday book over here, it's grayed out because no class is referring to it. Okay, so what we can do temporarily is we can just create a dummy test just for that. Okay, just declare something there. I would suggest, how about just in the root over here? So it's a very typical scenario because if the class is simply grayed out, so that means any changes you do are not going to be checked by the compiler. For example, if I just do anything crazy over here and then simply Control S, and then if I try to compile, the compiler is not going to complain. On the other hand, I'll fix that in just a moment. If I go to the root cluster over here, root class, and then I will simply just temporarily, I'm going to, so just to make sure the system execution can reach the new class at some point. So I would say local, and then let's say BB for birthday book. As soon as I hit compile, the system is going to include this class for compilation. So I'm going to say compile. Okay, so now you can see the crazy thing I did is now being checked. So now I just fix it back. Okay, hopefully you can see that every time I add a new class, if you see the class, it's actually grayed out. So that simply means there's nothing else in the existing system that depends on this new class. So you have to build that dependency yourself. All right, so now for the birthday book, so now we're going to think about how we're going to implement that. I'm going to suggest a naive implementation as follows. Let me illustrate it to you, and then we'll see what attributes we should declare accordingly. So this is what I would suggest. We are going to implement a birthday book. Basically, a birthday book will be a collection of people's birthday and their names. So let's say this. We're going to have two linear data structures, so we can also illustrate to you how you can use arrays and linked lists that we learned in the previous videos. So we have one array called names. We have another linked list called birthdays. And then the way it works is by corresponding to each index in the array and also the birthdays. For example, if I find index 1 over here, let me just highlight it. Index 1 for the names will be Alan. Index 1 for birthday will be September 4th. So that means Alan was born on a September 14th over here. So that's his birthday record. And also for Mark, index 2, his birthday correspondingly will be March 31st. And also for Tom, his corresponding birthday will be July 2nd. So index over here is really important. So that's something we will have to ensure that they correspond to. Each name has its corresponding birthday in the birthdays linked list. Okay, that's something we will have to make sure. Okay, hopefully the implementation makes sense to you, and then we're going to make it happen. Back to the code. So names is going to be an array of string, and also the birthdays is going to be a linked list of birthday, which we just worked on previously. Okay, so now first of all, let me simply just go here to say feature. Let's do attributes first. Okay, as I said, we're going to have names and birthdays, and then we'll do constructor in a moment. So we're saying names over here is going to be an array of string. And then birthdays is going to be a list of birthday. And I'll explain in just a moment why we are using list over here rather than linked list. That's something I will explain. It's related to a design principle which I mentioned previously. I'll get there. Okay. So these are the two attributes, and let's have a single constructor to begin with. Let's say in the birthday case, remember, let me just remind you quickly. In the birthday case, we actually got a constructor called make. Why don't we just give it another name? Because the name doesn't really matter. Why don't we say make empty? Okay, make an empty birthday book. So what I will do is I'm going to create another feature over here. Let's call that command. Okay, and then I'm going to say make empty. And every time, I would say the first thing you do about a particular routine is to just give some comments over here. So I would say create an empty birthday book, which means the names array will be empty, and also the birthdays linked list will be also empty, right? So you know how to do it already from the previous videos. And indentation is important here. Okay, so now this will be simply just empty just for now. Okay, and then we're going to have also, we had to declare the make empty as a constructor, remember, right? So we're going to say create clause, and then make empty is going to be one of the possible constructor that we allowed. Okay, so now so far so good. Now I want you to imagine one thing before I hit the compile button. If you simply translate this particular piece of code into Java, let's say you have a birthday book class, and then you simply got birthday book constructor, and let's say the constructor simply does nothing, in which case you will simply the names and birthdays attributes will simply get a default value null, right? Simply like a void in Eiffel case, right? Simply pointing to nothing. And would you see any compilation error in Eclipse in that case? I'm pretty sure you wouldn't, right? However, as soon as I hit compile over here in the equivalent code in Eiffel, it actually gives me something, some compilation errors. Okay, it's one of the most common errors that you will have by using Eiffel as a design language, because they impose some discipline called voice safety on the developer. Let me explain that. Okay, first of all, let's understand what's going on with this particular error. Let me read it first. It's a very common one. Variable is not properly set. Attributes, birthdays, and names. So because we're compiling this particular class, it's complaining that names and birthdays were not properly set. Although in Java case, you are not required to actually set the reference attributes. It's okay to let them have the default values null. However, in Eiffel, over here, they actually set in the make empty. Over here, you can see the make empty over here. Right? Make empty is one of the constructor over here. When you are trying to initialize the birthday book objects, Eiffel compiler requires that you must initialize every reference attributes. They cannot have the value void or null at the end of the object construction. It's a requirement. It's something called voice safety. So now let me explain to you what the voice safety issue is about briefly. So let me switch to my iPad. So I will try to compare how things will be done in Java, which you are familiar with, versus how things are done in Eiffel, which we're learning now. Let's first talk about declaration for variables over here. Okay, let's talk about Java, which you're familiar with. Let's talk about Java here. Okay, let's say we're talking about in the context of a person class. Every person must have a name, so this is required, it's mandatory. Whereas not necessarily everybody has a nickname that might be called by their friends or their parents, so let's say this is optional. So at the conceptual level, throughout the lifetime of a person objects, their name, field, or their name attribute should never be a null value, whereas for the nickname, it could be null, right? However, will the Java compiler of Eclipse complain if you simply do nothing in the person constructor, in which case both attributes will simply get the null value by default? The answer is no. The compiler simply wouldn't complain. So you can still execute your code at the runtime. So that's some little experiment you can confirm by yourself if you're not convinced. And the second point I would like to make is, if the name which is required at the conceptual level is allowed to have null value after the object construction, then it's very likely that later, throughout the lifetime of this particular person objects, you might have null pointer exception, right? Which is very notorious for any OOP programmer, right? It's our nightmare. So it's a null pointer exception. Okay, so the story goes like this. Eiffel designer knows that the null pointer exception is very costly for any software engineer to actually have. So they decide that maybe, okay, let me make an analogy to you. Rather than finding out the gear of your plane has some problem after taking off, which is the case where you only find out null pointer exception at the runtime. What the Eiffel compiler will try to do is they will try to identify the running gears problem for the plane before the takeoff is going to happen, so that you will simply be forbidden to actually take off, which means you will be forbidden to actually execute your code. You will get compilation error instead. But how so? So let's take a look at the declaration level. For Eiffel case, so Eiffel over here, let's talk about if I simply say name of type string. From how we understood before, we're saying that name is going to store the address of some string objects, right? So now from the set of string, all the possible string objects over here, and name is just going to store one address, okay? So now, I didn't mention that before, but it's good to say it now. If you compare this declaration over here and this declaration over here, semantically, they are not equivalents, which means they have different meanings associated with it. Okay. More precisely, when you declare this in Eiffel over here, you're saying that name can never be void, and void is actually the equivalent to null in Java. So I might sometimes use them interchangeably. Okay. So whenever you declare some attributes or variable of some particular class type, you're really declaring to the compiler that this particular variable can never ever store the void value. For example, if you go back to our declaration for the two attributes over here, you can see names is simply of type array, is a class name. And also birthday is also of some class name, which is of type some class name list. So that means we're declaring that there should be under no time that names and birthday can store void. So that's why in the original version here, at the end of the object construction by using make empty, names and birthdays will simply get a value void. So that's forbidden by the constructor. So you can think about this like identifying some running gears problem for your plane before takeoff. So takeoff is like executing your code at a runtime. Okay. So now, so what would be equivalence in that case? So now if you think about these two, nickname over here, if we use a keyword called detachable. Okay, let me talk about it here. So detachable is something that's optional for you. So by default, if you don't use detachable in Eiffel, if you simply use something like this, that is to say the name must be under no time voidable. Okay, it cannot be contain any null value. On the other hand, if you explicitly declare detachable, then you have the same meaning as the Java variable here. So I would say nickname and also nickname over here, they mean the same thing. So that means they're optional. Okay, so that's something you want to get used to. Okay, let me recap very quickly, and then I gotta move on to other things. What I'm saying is, in Java, they don't really have a way to support for the developer to ask the compiler to check for them, to say, I really meant this particular name to be under no time to be nullable. The compiler wouldn't check for you. If they rely on you to do things like nickname is not equal to null, or name is also not equal to null. You have to do such check by yourself. But sometimes if you didn't do systematically enough, you might just run into null pointer exception. On the other hand, Eiffel does require the developer to commit to one decision or another. So let's say if I declare nickname to be detachable, it's a modified keyword, so which means you can use it if you wish. So detachable string. So that means nickname may be void. So it is okay to not to initialize the variable at the constructor. That's fine. Okay. On the other hand, name over here, since there's no detachable in it, so that means the string value should always be some actual string. It can never be void. Let me talk about another point. Having known this, so how do we check for null pointers? In the Java case, we know very well, in order for you to check, you would say not equal to null. And the whole thing over here is going to return either true or false. It's a Boolean expression, right? We have the equivalence also in Eiffel. So that's a keyword you have to know. So there are 2 keywords you got to pick up. 3 keywords actually. Let me write it down. So there are 3 keywords you want to pick it up from this particular slice. You want to know about a keyword called void. You want to know about a keyword called detachable. And also you're going to know about a keyword called attached. And we will hope to get you some exercise on at least these 2 later in the video. We'll see. Okay, so these are the 3 keywords you want to pick up about void safety. So the corresponding way to check for null pointer is like this. If I want to make sure the nickname over here, because optionally the nickname is detachable, which means it might point to void. It might be storing nothing about the objects. In that case, you can use the keyword attached. So when I say attached some variable name, I'm basically checking that that particular variable is not equal to null or not equal to void. So they're equivalents. You will see use cases of this later. Okay, the conclusion from this particular slide is this question. So which variable will actually require initialization? The only one that will require is this particular one in Eiffel case. Only this one here. In the case of Java, both of them don't require the variables to be initialized. It completely relies on the developer to do the null pointer check. Okay? In the Eiffel case, if you explicitly declare something to be detachable, and then the initialization is not required. Okay? Hopefully that makes sense to you. Try to review the story over here. It's a very quick overview, but hopefully we'll see more examples. So it's better to learn by examples. So before I go back to Eiffel Studio for coding, I'll refer you to the written notes for this particular tutorial series. If you go to the corresponding section for this particular video here, so I will refer you to this section there, simply a little bit more details about void safety. I would suggest you read that particular page. It's summarizing bullet points, very precise and concise. I would suggest you read it, so that can be a very good supplement to what I just said on the iPad. Okay? Okay, so now let's go back to the Eiffel Studio for more coding. So we know that because names and birthdays by default they should be attached, so they should be never null or they should never be void. So now let's initialize them. Okay, so we know about how to create variables, how to create objects from the previous video. Let's just do it directly. So we have to say create over here, and then what's the dynamic type for names? And we can just use array. Array is good enough. Okay, so I would simply say create names dot make empty, for example. That's let me just say equivalent to this, simply equivalent to over here creates array of string, and then we can say names dot make empty, simply because dynamic type is simply the same as the static type over here. As I said before, it can be omitted. Okay, so that's the first one. What about the second one? The second one here is interesting. Remember, in the very earlier stage of this tutorial series, I asked you to do one exercise for me, which is to look up the descendant classes of the list class. If you have done it, good. If you haven't, I would encourage you to do that a little bit before you go on. Okay, so let's go on. Let's now see, let me just try one thing here for you and let's see what happens. If I simply say creates, and then what should be the dynamic type for birthdays? Well, what about the list? Let's go to the list first of all. If I go to the list over here, you can see list class is actually deferred. Remember what I said? I said the defer here is like an abstract in Java, which means this class is only partially implemented. We know in Java that the abstract class or interface class cannot be used after the new keyword, meaning that they cannot be used as a dynamic type. And similar rules apply in Eiffel. Defer class simply is like abstract class, partially implemented, so we cannot use it. So that is why. Let me just show you anyway. So let me go back here. So if I simply say, let's say, let me just copy that so I can save some typing. If I simply put curly brackets over here, that means I want to use it as the dynamic type. And then I would say birthdays dot make. For example, let's say, remember the make feature we talked about for linked list, right? It's going to create empty linked list. Will this compile? It shouldn't, right? Because how can I use an abstract class or defer class as the dynamic type? If I say compile, we're going to see exactly that one there. Okay, let's just read this. I think this is informative enough. Okay, creation instruction applies to targets of a deferred type. Specifically, it's referring to the list over here, deferred classes, right? You can see where my mouse pointer is. So the list over here is deferred, so we cannot use it as dynamic type. So now, what are our choices over here? You might be wondering, why didn't you simply just declare this guy here to be linked list? Why not, right? If I simply declare this to be linked list, and then here I don't even have to worry about putting this one, it can be omitted, like the case for array. There is a reason for this. So I'm trying to show you a design principle here called programming from the interface, but not from the implementation. Okay, I'm just using this one to illustrate to you. Let me switch to my iPad, and then we'll come back to finish the coding. Okay, so now let's see this. So the design principle is actually quite an interesting one. You may have seen this maybe without knowing the name in your OOP class previously. Okay, let's it's called program from the interface, not from the implementation. The principle really says whenever you want to declare some variable, the type you actually choose should be as general as possible. We'll put it this way. Always, if you have an inheritance hierarchy tree like this, the class to be the static type should be as high as possible on the tree, which means it should really contain as many descendant classes as possible. Let's say this. Over here, birthdays is actually declared to be a list. And now, let me just show you very quickly, right? Because there's some exercise assigned to you. I shouldn't do it for you, but I'll just show you the important points. If now I have the list class over here in Eiffel Studio, how do I show all the descendants? Okay, very quickly. Let me double click on the tab, and let me choose the class tag over here. Okay, and then you can see there is a button here. It's called descendants. Let me click on that first, and then highlights the list. Right click, drag, right click to drop. So these are all the descendant classes of the list class, right? It's really important for you to know how to use the tool to help you develop. So now you can see the list is actually the top level of this hierarchy here. So the diagram I'm showing to you here is just simplified view, just to for illustration. You can see list itself. You can see there's a red circle around the top left corner. So that means list itself is deferred or abstract. And then itself has 1, 2, 3, and 4 immediate child classes, and out of them, dynamic list and also parse sorted list are also deferred, under which you can see you can expand further to build a tree, right? So my exercise previously was how many subclasses can you actually choose as the dynamic type if the list is the static type, right? That's actually for this purpose, for this part of the video. Okay, so assuming that you have done that a little bit, so let me go back. Let's consider a simplified view of the inheritance hierarchy, meaning that you can see the list is the static type over here. Okay, let me just annotate for you. The list over here is the static type of birthdays. So now, what can be the dynamic type? So now here, when I try to create an object, creation of objects at the runtime, right? So now I use a creation instruction, and now dynamic type over here may or may not be the same as a static type. Actually, we should have options if options are available. So now what can be the options over here? So I would say we're gonna review the inheritance topic later in the course, but just for now. So the rule would be it could be all the descendants classes of list. So in this simplified view, what are the possible descendants over here? Okay, let me just use green. Not this one here, because the reason I put a star here is a notation of the diagram, which you have to follow later. We'll have a lecture for this. Whenever I have a star besides the class, that means the class is also deferred. So of course it cannot be the dynamic type. So I should be more direct over here, not just descendants, but concrete descendants. Concrete means it's fully implemented, and the term we're going to use is also called effective. It's completely effective, the descendants. So that means every feature is implemented. So what are our choices? For example, linked list is an effective descendants, and also array list. And another branch, we also got parse sorted two-way lists. So now in this case, we got at least 1, 2, and 3. So the advantage is, so now by declaring the static type to be something that's general enough, So now we have different choices over here. We can say maybe for now we think maybe linked list should be a better implementation for efficiency. So we just bind it at runtime to linked list. But later on we might decide rather than using this particular linked list, we can choose just another one for whatever reason, either for efficiency or for maybe correctness or whatever, right? So we give ourselves the flexibility to change the binding dynamically, whereas the static type stays the same. So it's a very important design principle. It's called program from the interface, in this case, list, not from the implementation. Rather than you simply put, for example, linked list over here. If you put a linked list over here, what options do you have? So that means you're narrowing down the possibility into all the descendants of linked list. If there's simply no descendants class of linked list, let's say there's no subtree, in that case, there's no option for you for the dynamic type. You can see you're in a much less flexible situation. Okay, that's very good. So now let's say for our case, we're going to choose a particular effective descendants for the dynamic type for list. Let's say we choose the linked list, let's say, for our tutorial. So let me go back to the Eiffel Studio over here. Okay, let me maximize this, and then so now rather than list, I'm going to put linked list. Okay, let me just remind you over here the principle. Program from the interface, not from the implementation. Okay, and the details you can definitely watch the recording if you forgot. Okay. So now let me just try to compile. So now everything compiled for our birthday book class over here. So far we have done the following. We have done the names and birthdays decoration, and we applied this particular design principle. And you can see the dynamic type we chose was actually one of the effective descendants of list. And we also talk about the voice safety issues about detachable versus attached. So I would suggest to really get a better understanding about the voice safety issue, I'll refer you to the written notes for this particular tutorial video. Go to the corresponding section for this video here, and then the second page on that, you will actually see the voice safety, very brief summary of the issue here. Hopefully that will help you your understanding. Okay, review all the issues here, all the points before you move on to the next video.